we're going to use the definition of the derivative to differentiate f of x equal to square root of sine x. Now there's already a video that shows you how to do that. In this video we'll use a different method, that is, we use a different trig identity to do it. So it's another way of doing the same thing, but I think it's well worth knowing. To do it, we'll need the following three results. The first one is the trig identity, which is sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. The second result we'll need is the limit as h approaches 0, sine of h over h equals 1. And the third result we'll need limit h goes to 0, cosine of h minus 1 over h equal to 0. Let's recall the definition of the derivative. The definition of the derivative, f prime of x, is the limit as h goes to 0, f of x plus h minus f of x divided by h. So in our case, that's going to be the limit as h goes to 0 of the square root of sine of x plus h minus the square root of sine of x over h. So the next step is to multiply both the numerator and denominator of this limit by the conjugate of the numerator. So this becomes limit h goes to 0. We have the square root of sine of x plus h minus the square root of sine x over h. And we multiply that by the square root of sine of x plus h plus the square root of sine x divided by the square root of sine of x plus h plus the square root of sine x. So this will remove the radicals from the numerator. The numerator now looks like this. H goes to 0. We just have sine of x plus h minus sine x. And the denominator has h times the square root of the sine of x plus h plus the square root of sine of x. Now we'll use the first result on sine of x plus h, use that trig identity and expand it. So alpha is x and beta is h. Now we have limit as h approaches 0, sine of x times cosine of h plus cosine of x times sine of h minus sine x all over h times square root of sine of x plus h plus the square root of sine x. Now let's do a little bit of factoring. The first term here has sine x, so does this last one, so we can factor out sine x. And then so we write this is the limit as h goes to 0. So this is sine of x factored times, we have cosine of h left minus 1, then plus cosine of x times sine of h all over h times the square root of the sine of x plus h plus the square root of the sine of x. So now we'll break this up into two limits. Because of the plus in the numerator, we can break this up and write it as a sum of two limits. This is now equal to the first limit. We have limit as h goes to 0, sine of x times cosine of h minus 1 divided by h times the square root of sine of x plus h plus the square root of sine x. And the second limit, that's limit as h goes to 0, cosine of x times sine of h divided by h times square root of sine of x plus h plus the square root of sine x. Now let's further break these two limits into products of limits. The first limit here will be limit as h goes to 0. We'll take sine of x and divide it by the square root of sine of x plus h plus the square root of sine x times the limit as h goes to 0 cosine h minus 1 over h. Notice that this limit right here that I'm circling, that's 0. So this whole first limit will be 0. It doesn't matter what this becomes, because this is just going to be sine x over 2 times square root of sine x, and times 0 will be 0. The second limit will be written as a product of two limits also. The first one is limit as h goes to 0 of cosine of x divided by the square root of sine x plus h plus the square root of sine x times the second limit is the limit as h approaches 0 of sine h over h. So now we're ready to evaluate. Let's go ahead and compute everything. This first limit, as I said, is 0, but we can write it as sine x in the numerator divided by, as h goes to 0, we have square root of sine x plus the square root of sine x, but since the second limit is 0, this is times 0, plus, let h go to 0, we have cosine of x in the numerator, similarly divided by the square root of sine x plus the square root of sine x. But then the second limit as h goes to 0 of sine h over h, that's 1. And so we arrive now at the final answer. We can simplify cosine of x divided by square root of sine x plus square root of sine x as cosine x in the numerator divided by 2 times the square root of sine of x in the denominator. So let's summarize what we've done. We just used a slightly different way to take the function f of x equal to the square root of sine of x and show that its derivative is equal to cosine of x divided by 2 times the square root of sine x. And for more videos, visit www.mathprepvideos.com.